And of course they're liking getting a second variable involved. When there's a shape with two variables, automatically think the topic differentiation, automatically think this is paper 2. This is actually a paper 1 question, but it's normally paper 2. And also think, if you haven't got the time or you don't want a high grade, skip questions A and B. Question A, find an expression for the perimeter in terms of X and Y. So this is only 1 mark, but I think this is such a long 1 marker. Why? Because you have to do a lot of thinking. First of all, we need to think of the perimeter as 2 arcs, because this is one of the arcs here, this is one of the arcs here, plus each of the y's, this y and this y. So that bit is easy, but then we still need to do a bit of working out to work out what this arc is. You need to understand that 2 arcs added together is a full circle. So what you need to think of is, what is the circumference of a full circle, which is pi d. So pi d plus y. Please check my answer to see if you agree, because we need to make sure I'm doing this fully correct. So diameter is the distance going all the way across a circle, which is going to be x. So there we go, that's 1 mark. I think that's a lot of work. Question B. Show that the area can be expressed as something to do with x. So the reason why you can skip A and B is because it's already given you the answer to B. Now, how on earth do we do this? Well, first of all, we need to realise that we've got a y here and we don't want to have the y in the sentence. And another thing we know from the previous part is that the perimeter is 20. So we've got one equation now where we've written y and x and 20 together. Because we want to eliminate the y, the first thing you're going to do in any differentiation question like this, where it's a real life problem and there's 2 variables, you're going to rearrange one of the formulas so that it's in terms of another letter. So we're going to rewrite this in terms of y. So we will have the formula like that, but now it's in terms of 2y. So actually we're going to change it so it's 20 divided by 2, which is 10, and then minus pi divided by 2x. So that is one formula. So why is that useful? Because when we're differentiating, we need just one variable. So now instead of writing y, we can write y as 10 minus pi over 2x. Now, yes, that is a lot more complicated and confusing, but now the whole problem is in x, which makes the examiner happy. Now, again, this is ridiculous for 3 marks, because we now have to combine information from the blue boxes to find the area. So the first thing you're going to do is you're going to find the area of the full circle, which is 2 semicircles combined together, which is pi r squared. That is the full circle. Then we're going to find area of the box. The box, or the rectangle, is going to be this length times the height, which is x. So the height is x times the length, which is this. Now, you are hopefully starting to see why I would recommend avoiding this in the exam, unless you want a 6 or a 7. Now, we need to rewrite r in terms of x. X, I believe, is going to be to do with r because we need to half it. So we need to take half of x to get to the radius, because the diameter is x, so half of x is the radius. Then we need to start expanding this out, plus 10x minus pi over 2x squared. Then we need to expand this out. Pi x squared over 4 plus 10x minus pi over 2x squared. I would really recommend you don't bother with that in life unless you want a 7. Right, so we've done A and B. C is where it starts to get much easier. And you should be able to make up a bit of time with C. So, a lot of you would have been scared to differentiate this because it has a pi in it, but just think of that as a number. So how are we going to do that? Well, first of all, I would label this as A, and then if you're going to differentiate it, we're going to do A dash. So wherever there is a variable with an x, that obviously just goes, sorry, wherever there is a number and an x, that just changes to just the number. And then With this one, obviously, if we're differentiating x squared, like we talked about in the previous question, that just goes to 2x. Now, we've got 2x pi, 2 over 4, which simplifies to 1 over 2. So the answer is simply going to be 10 minus x pi over 2. But you could have left your answer like that and you would have got the answer, I believe. Yes? Where did the square go? Because whenever you differentiate x squared, that always differentiates to 2x. Do you agree with that? So I believe that's right. The only thing I could do to improve my answer a little bit is to move the x after the numerical value of pi. Then, parts D. We now need to work out what the solution is to this problem. When we differentiate something to find the solution of a problem and to find when a maximum or minimum happens, it's when the gradient function is equal to 0. When the gradient is equal to 0. What on earth do I mean by that? Well, if we go back to the original function, and we know this is a negative quadratic, we know it probably goes through 0 because there's a 0 intercept. It's going to look a little bit like this. I don't know the exact shape it's going to have, but it's going to be something like that. So in order to find the solution to this problem, we're going to set this equal to 0, and then that will give us a solution of a maximum or minimum. This is a quadratic graph, so it will only have one solution. You set that equal to 0, you can solve it on your calculator, or you can just do it manually. If you're doing it manually, you're going to move this onto the other side so it becomes positive. Then you're going to flip it the other way so it becomes 20 over pi. In the exam, it said to leave your answer exact. So you should have left your answer like that. I think there was only one person in this class who got close to that. And I think they're sat in the room right now. So you can see A and B, particularly B was impossible. C and D, much easier. Always with differentiating. Differentiate nice and easy. Set equal to 0. Have one or two solutions. There's one solution if there is a... there's one solution if there's a quadratic. There'll be two solutions if it's a cubic. I've just realised this graph, even though it goes through 0, 0, it's going to look more like this. The reason why is because we know it goes through 0, 0, but the maximum occurs at roughly 6 something. So this is where the maximum is going to occur, which is what the x value is. If you wanted on paper 2 to find out what the y value is, you just substitute that x value back into the original formula, which is here, and that would give you the y value, or in this instance what the a is, which is the y, and the x is going to be this length here. Any questions about that?